Alright, on to the next question. We need to show that this statement here is divisible by 2015. So we've got all the odds up until and including 2013 multiplied by each other, and all the evens up until 2014 multiplied by each other. So notice how you have 1, then you got the next one there, 3, 4, 5, 6, 7, 8, da, da, da. So essentially in this expression we've got all the numbers 1 to 2014 but been split by odd and even. So we need to work in mod 2015. So let's see this 1. So we've got 1 times 3 times 5 up until 2013 plus 2 times 4 times 6 2014, and this is congruent to, well, let's just look at the numbers in the first brackets, 1, 3, 5, 2013. None of them can really be further reduced by mod 2015. So we can say that these numbers stay the same. Now look at this 2. Well, if you look at 2 mod 2015, we have minus 2013. Why could this be useful? Well, we've got a minus 2013 in the first bracket. So let's just continue this idea for a bit. So we've got minus 2013 for mod 2015 is times minus 2011 up until, well, 2014 mod 2015 is minus 1. So essentially we've got the same numbers in the brackets, but in the second bracket we've got a minus for every term. So let's evaluate this. Minus 1 times minus 3 times minus 5 up until, so let's make this a bit clear. Minus 1 times minus 3 times minus 5 up until minus 2013. And if you call this bracket A, you want to find out whether this is A or minus A, and the way we'll do this is by finding out how many minuses there are. If it's an even amount, we'll have positive A, and odd amount, we'll have negative A. So how do we find this? Well, we need to find out how many terms there are in this sequence. So let's say minus 1 is term 1, and and we need to find the term rule and make that equal to minus 2013, and then solve for whatever variable we've used. So let's say first term minus 1. So and the formula is A, where A is the first term. That's A plus n minus 1 d. Now here the common difference is minus 2. So we've got minus 1 plus n minus 1 minus 2. If we expand this, let's call this un, sure, tn, minus 1 plus minus 2n plus 2. So we've got minus 2n plus 1. That's our terms to our rule. So let's check this works. Minus 2n plus 1 when n is 1 is minus 1. When n is 2, minus 3, blah blah blah, checks out. So minus 2n plus 1 equals minus 2013. Minus 2n equals minus 2014. N equals 1007. Nice. So we know that there's an odd number of terms, meaning that this sequence here equals minus A. So that works out quite nicely, because we know that we have A minus A, which is congruent to 0 mod 2015, and therefore we have shown that this number is divisible by 2015, as we are left with the fact that it's congruent to 0 mod 2015. So, nice question. Question 6. There's a pile of eggs. Joanne counted the eggs, but count was off by 1 in the ones place. Tom counted the eggs, but his count was off by 1 in the tens place. Raul counted the eggs, but his count was off by 1 in the hundreds place. Sasha, Jose, Peter, and Morris all counted the eggs and got the correct count. When these 7 people added their counts together, their sum was 3,162. How many eggs were in the pile? Right, let's start off by depicting pieces of information from this paragraph of words. Well, a pile of eggs, let's call this N. Joan counted the eggs, but her count was off by 1. So if you go to Joan, let's write in black actually. Joan, her count was off by 1 in the ones place. That means it could have been 1 too great, 1 too small. So we can say N plus or minus 1. Now Tom, on the other hand, his count was off by 1 in the tens place. We have N plus or minus 10. And then you can expect for Raul, his count was off by 100. So that's N plus or minus 100. And the other 4, Sasha, Jose, Peter, and Morris, they were all spot on. So we can say N. Now the next piece of information told that when we add their counts together, their sum was 3,162. So let's add all of this. So we have 3,162 equals 7n, because there's 4 people here, so 4n and 3n from above, plus or minus, well, we got plus minus 1, 10 or 100. So let's write all of this as x, where x is a set of numbers, possible numbers. So x starts with the smallest possible number, which is minus 111, and it goes all the way up until 111. There's 6 terms in this sequence, as we can choose 2 from here, 2 from here, 2 from here. So 2 plus 2 plus 2 is 6. Or is it 8? Let's think. Choose 1, 2, 3. I think there's 6 or 8. Actually, there's 8 elements in this set, because we can choose 2 from here, 2 from here, 2 from here. So we do 2 times 2 times 2, which is 8. And we can say 3,162 is equal to 7n plus x. Now, since we know that n is a whole number, we can use modular arithmetic to reduce this number. So 3,160n equals 7n plus x. So 3,162 is congruent to 7. Is congruent to mod 7x. 7n disappears, is a multiple of 7. Now let's try to reduce this 3,162 using mod 7. The closest multiple of 7 I know is 2,800. So 2,800 minus this, minus from here is 362. And then try to reduce this further. We have 350 is multiple of 7, so we say 12 is congruent to 7 mod x. That means 5 is congruent to 7 mod x. Sorry, I'm saying that wrong. 5 is congruent to x mod 7, which also means minus 2 is also congruent to x mod 7. Now, what can we do with this information? Well, by finding x, we can sub this back into here, solve for n to find the total number of eggs. So let's look at x. Well, last, we're working in mod 7 here, so we need to also apply the same logic to plus or minus 1, 10 and 100. So plus or minus 1 mod 7 is simply you do 1 plus or minus 3 equivalent to sorry, not 3, we're working with 10 is equivalent to 3, and plus or minus 100 is equivalent to 2 mod 7. So now we know plus minus here and plus or minus here, and we use 1 from each line, plus minus 1, plus minus 3, plus minus 2 to form either 5 or minus 2. Well, we can choose either 5 or minus 2 because in mod 7 they mean the same thing. So let's say x equals minus 2. Now we need to find how do we make minus 2 using these numbers. Well, the only way I can see is minus 3. Let's write mod 7 minus 3 minus 1 plus 2. So if we come back out of the mod world, minus 3 comes from minus 10. Minus 1 comes from, well, minus 1. Positive 2 comes from 100. So x equals 89. So that's all good. So 3,162 equals 7n plus x, which is now we know 89. 3,162 minus 89. So 3,162 minus 100 is 300. And 3,062 plus 11 equals n. 3,073 equals 7n. N equals 3,073 divided by 7, which is just, let's just use division, long division, short division, whatever. 4 to this is 3, 6, 439. So n equals 439. So now we've got the number of eggs in the basket. Nice.